Settings files are a convenient way to store and edit offline settings for UR relays. They offer a simple and comprehensive way to create, edit, and save settings for a device in a single file. The operations associated with settings files are grouped in UR-PC under the Offline menu and appear in the lower left panel. If you don't see this panel, open the View menu and check the Offline window menu option. The same options applicable to settings files in the Offline menu are also displayed when right-clicking anywhere in the Offline panel. We'll start by creating a new settings file. Sure enough, we select New Settings File from the menu. The file is stored on your hard drive as a comma-delimited text file having the extension .urs. On the dialog that pops up, we have to enter a name for the file. For the sake of example, we'll call this file F60 test. Next, we need to enter the order code of the relay. Note that the settings file is closely related to the order code and that you cannot change the order code of an existing settings file, so it's important that you enter the correct order code the first time. We'll enter the order code for an F60 relay. Next, we select the version that matches the firmware of the device, in our case, 3.0. Press OK, and the file is saved to the hard drive. Upon expanding the File node in the Offline panel, we see the file that we just created, f60test.urs. By default, the file is stored under the installation path of UR-PC in the subdirectory called Data. If we expand the File node, we see a tree structure similar to the Settings branch for an online device. Take a look at the Markham North cell site on the online tree where we have one relay, F60 Markham North, set up to compare the two windows. Coming back to the setting file, we expand the Product Setup node and open the Display Properties window. The values associated with each item come from an internal UR-PC database and are at the default values. As you may recall from the Settings section, all settings remain at their default values until they are updated and programmed into and read by the relay. The functionality of a settings file screen is identical to that of online settings. The only difference is that the changes are not live. Let's edit a setting offline and save it to the settings file. We'll change the default message intensity from 25% to 75%. Press Save, and the setting is saved to the file. Remember this change. We'll come back to edit it again a little later. Note that when a relay setting is changed in the settings file, it is saved to the file only and must be written to the device in order to take effect. Observe that the LED indicator on the status bar of the window of an offline device is gray, signaling that no live communication is active. Now, if we have a settings file created and want to load it in UR-PC, from the Offline menu select Add Existing Settings File. A pop-up box that enables us to browse for the file appears. We'll select the file f60sets.urs from the hard drive and click the Open button. Collapse the tree on the Offline panel to see our file loaded in UR-PC. UR-PC also allows us to create a duplicate of a settings file. This is useful when you want to create a settings file that is close to an existing one, but has some differences. This is a handy tool because settings files can be quite large. Up to 6,000 settings are possible on a single device. To duplicate a settings file, first select the desired file in the Offline panel. We'll use f60sets.urs. From the Offline menu, select Duplicate Settings File. A file named Copy of f60sets.urs is created on the hard drive and added to the UR-PC Offline panel. To remove a settings file from UR-PC, select the file that you want to remove from the Offline panel. We'll remove Copy of f60sets.urs. From the menu, select Remove Settings File. A dialog will appear for confirmation. If you select Yes, the file will be removed from UR-PC but will not be deleted from the hard drive. This way, it can be added back to the UR-PC later if we so choose. Let's look at how settings files are read from and written to a UR relay. First, we'll look at a simple demonstration of how URPC reads the settings from a UR. We already have a relay and a settings file with the same order code and a version set up here. From the online menu, select the Display Properties window. Open the same screen from the settings file. We now have the relay settings on top and the settings file at the bottom. Observe that they differ in default message intensity, with the relay having a value of 25% and the settings file a value of 75%. Right-click on F60 Markham North from the Online panel and select Read Device Settings. A dialog will appear that prompts us to select the target file to receive the settings. Note that we can select a file that is already loaded in the URPC environment or a file that is located somewhere else on your hard drive or on the network. We'll select the file f60 test.urs and press the Receive button. When the process is finished, the value of the default message intensity in the settings file updates to match the 25% value from the relay. This confirms that the settings were read from the relay and stored in the settings file. Reversing this function, writing settings from URPC to a relay, is just as simple a process. We'll set the value of the default message intensity to 50% in the settings file f60 test.urs. From the offline menu, or the panel right-click menu, select Write Settings to Device. A dialog appears that allows us to select the target device from the URPC environment. We'll select the device F60 Markham North and press Send to write the settings to the device. Alternatively, transferring settings between the device and the settings file can be achieved using Windows drag and drop. This operation lets you move portions of the settings back and forth. For example, start with the two settings windows for Display Properties open, with the relay settings on top and the settings file at the bottom. Drag the settings screen on the upper panel to the F60 Markham North device tree and release the mouse. The display message intensity setting on the device will change to 50% to match the value of the settings file. The same operation can be done for a group of settings. Let's say initially we select Product Setup and drag this section to the device. Then all the settings under Product Setup, like Display Properties, Oscillography, and Fault Report, will be transferred from the settings file to the device. As you may have assumed, this operation can be used to transfer settings from the device to the settings file in the same way. URPC also allows us to revert a settings file back to factory default values. The software keeps an internal database with the factory default values of all settings for each product and version. At any time, we can revert all the changes made in a settings file back to the factory default values. Let's try performing this operation. We open the file f60 test.urs and the Display Properties window. Recall that we had changed the default message intensity from 25 to 75%. Now, from the offline menu, select Set to Factory Default Values. As expected, the value is reverted to 25%, the factory default value. When a user decides to upgrade the firmware of a relay to a newer version, one of the concerns that may arise is retaining the relay settings. To address this, URPC enables the user to convert the settings file from one firmware version to another. The values of the settings that are common between the versions are copied from the old file to the new file. The values of the settings that are new to the firmware upgrade are set to the default value. A report will be generated on the screen displaying all the differences. Let's take a look at how this works. We'll presume that we have a settings file f60 test.urs with the shown order code in version 2.90. From the settings file screen, we open Display Properties, and we set the value of the default message intensity from 25% to 75%, and save the settings to the file. For an illustration we'll use later, we'll create a copy of this settings file using the Duplicate Settings File function. From the File panel, we select f60 test.urs. and from the Offline menu, we select Convert Settings File. A dialog will pop up for converting the setting files. At the top, we have the name and location of the settings file. In the source information, the order code and version of the file is displayed. In the destination information, we have the option to change the version of the destination file. The order code of the destination file is the same as the order code of the source file. We'll choose 3.0 for the version of the destination file and press the Convert button. A progress bar will show the progress of conversion. At the end, a screen will be displayed summarizing the results of the conversion. Let's take a look at the information in this report. At the top, the name and location of the original file is shown. On the second line, you'll see the name and location of the backup file, f60test.urk. Before the conversion takes place, the original file is backed up. This assures that if you are unhappy with the conversion process, you can still go back to the original file. Following that, the report has 3 sections. The first section, Settings No Longer Available, specifies the settings that were available on the previous firmware version but are no longer present in the new version. This is expected when the firmware implementation of a specific feature was changed between the versions and the new implementation requires new settings. The old settings for that feature are obsolete and removed from the settings file. On the report, the setting label that was removed and the screen where it is configured is displayed. If we scroll down on the report, we find the next section, Settings Reset to Factory Default. This section reports all settings that have been reset to their default values. An example of this can occur when the new firmware imposes a new range for a given setting. The setting will be reset to its default value if it is outside of the new valid range. The next section of the report, New Settings, indicates the settings that were added to the file in light of the firmware change. These settings are a result of additions to the new version or an improvement of an existing feature that was changed in implementation. We'll scroll down on this report to take a look at the new settings. Notice 3 new settings in the Product Setup Display Properties screen: Screensaver Feature, Screensaver Wait Time, and Voltage Cutoff Level. Now if we open the Display Properties screen in f60test.urs and in the copy of f60test.urs, we see on the left the settings from the version 2.90 and on the right the settings from the version 3.0. Notice that for the default message intensity, the value of 75% was preserved in the conversion process. Also in the 3.0 version, the same feature has more settings, the 3 we saw on the list, plus another that was higher on the alphabetically ordered list.
The UR event recorder is a sequence of events record of the relay's activity. URPC can help you retrieve and examine the captured events in a user-friendly table format, in chronological order. Let's take a look at the functionality that URPC adds to the event recorder. From our environment setup, we'll use the relay T35 Markham North. To start fresh, select Commands, Clear Records, and clear any existing event records. All events previously stored in the relay are now deleted. Now navigate to Actuals, Records, Event Record, and open the Event Record Viewer. A message will briefly appear showing that the event records are being read from the relay. The Event Viewer now appears on the screen. Observe that we have a single record on the viewer with Events Cleared displayed in the Cause column. Also displayed here is the current number of records and a very accurate timestamp of the event. Before we go into more detail on the viewer, we'll generate a few events. Open the Inputs-Outputs branch and Contact Outputs. Change the event for the Contact Output 1 setting from Disabled to Enabled and save the setting to the relay. In doing so, every change in the status of Contact Output 1 will create a record in the event recorder. Close this window and test a forced change in the Contact Output status to verify the event is recorded. First, we have to enable the Test Mode function and save this setting to the relay. Now, force Contact Output 1 to the energized state, meaning that the contact will be read as closed. Save the setting to the relay, and close this window. Now we'll go back to the Event Record Viewer. We observe that, for now, nothing has changed on the viewer. We still have only one record displayed. However, at the top of the viewer, in the Events Since Last Clear field, is 3 events. This field is updated periodically by the viewer that is communicating with the relay. On the tree, close the Settings section. In order to make the viewer read and display the new events, we have to close the viewer and reopen it. For a better view of the viewer features, we'll close the Online window on the left side. At the top of the viewer, we have the file name and the location on the hard drive where the file is saved. The second line shows the date and time of the event clear. The third line shows the number of events captured by the relay. On the fourth line, in blue and green, we have 2 time icons and a delta T time field. The yellow field displays the time difference between the events marked by the icons. Here, icon T1 is active. If you click on Event 1, the T1 icon will be positioned on Event 1. Now we'll click on the T2 button to make it active. If we click on Event 3, the T2 icon will move to the Event 3 position. Observe that the delta T value changes respectively. Let's clarify the events shown here. Event 1 was generated when we started by clearing the events via a command. Event 2 was generated when we saved the setting to the relay that enabled the test mode. And Event 3 was generated when we saved the setting to the relay that energized Contact Output 1. The Event Viewer also includes a sorting function. By double-clicking on any column, for example, Event Number, the rows are sorted by that column. If we click on the column again, the sort is done in reverse order. We can also sort the events by cause. Finally, we can use the Find function to locate information in a column. First, click on the Cause column. From the toolbar, click on the Find icon. We'll search for the word Events. The term Events in row 2 is now highlighted. You can continue with Find Next or close the dialog box. In this tutorial, we'll program the oscillography in an F60 relay to record 1 analog and 1 digital channel. We will then retrieve the file and change our preferences to examine the data. We'll start by selecting Oscillography from the Settings window. A number of oscillography settings appear, starting with the number of records. The upper limit for this value is 64 records. The trigger mode parameter can be set to Automatic Overwrite or Protected. By keeping the parameter at Automatic Overwrite, a new record will automatically overwrite the oldest record. The trigger position setting determines how much pre-trigger information will be stored in an oscillography file. The trigger position is programmable as a % of the total buffer size. For example, a trigger position of 25% consists of 25% pre- and 75% post-trigger data. The trigger source represents the signal that will initiate capture of oscillography. The trigger source can be any flex logic parameter. For example, an element state, a contact input, or a virtual output. The AC input waveform setting represents the sampling rate for the analog values. This can be set to off, 8, 16, 32, or 64 samples per cycle. Higher rates provide more resolution but use more memory. To set up, we have to select the data that we want to record on each of the 64 digital and 16 analog channels available. In this example, we'll choose 1 analog and 1 digital channel to record. We'll start by setting the trigger source to On. For the first digital channel, we select Virtual Output 1 On from the list. Similarly, additional digital channels can be set to the desired operands in this window. Now scroll down on the screen to select our analog channels. For the first analog channel, select Source 1 Current A RMS. Save the settings, then close the settings window. Now, retract the product setup and open the Commands branch. Open the Clear Records window. From here, we can clear the oscillography records in the relay. This will delete any existing oscillography files stored in the device. A confirmation message will appear on the screen. Click Yes to clear the oscillography. A message will appear indicating that the command was executed successfully. Now, on the tree, navigate to Actual Values, Records, and Oscillography. Here, we observe that there are presently no oscillography records in this relay. Recall that our trigger for oscillography is the flex parameter ON. Press the Force Trigger button to generate an oscillography. We see that the data on the screen updates, and one oscillography record becomes available in the relay. To retrieve this file, press the Read button. The record is read from the relay, and the oscillography viewer will show the data retrieved. For a better view of the oscillography screen, close the Online window on the left side. Observe that the screen is divided into three sections. At the top left, we have the trigger date and time, as well as the playback rate, and a button that will open the phaser screen. On the top right, we have the slide control associated with the two cursors in the oscillography file. If we scroll to the right, also displayed is the time difference between the two cursors. On the left side, we have a window that shows the signal value at the blue cursor, the value at the green cursor, and the difference between them. On the first row is the signal current phase A. This signal was not part of our selection. It's part of the basic set of analog values that are recorded by default for each oscillography file. Also included in this set are voltage signals. On the main window is the Graphical Viewer. This is where each signal is shown, as well as the adjustable blue and green cursors. The position of the trigger is fixed and represented by the red cursor. From the toolbar, go to Preferences. Here we can switch to Analog Signals. At the bottom of the list, we see our signal Source 1 Current A RMS. Click on Display Order column and change the display order for the second, third, and fourth signals to None, and last signal, Source 1 Current A RMS, to Automatic. To easily differentiate the signals on the graph, we'll change the color for the current source signal from blue to yellow. Now we'll go back to the digital signals and change the color for our virtual output from blue to red. Finally, we'll click on the Display Order column and change the display order for the virtual output signal from None to Automatic. Press OK on the dialog to save our preferences. We now have one of the default signals, F1 Current A, together with our own selection of analog, Source 1 Current A RMS, and digital Virtual Output 1 On, recorded. Continuing where we left off in the oscillography setup section, let's look at some of the oscillography viewer features. We'll first direct our attention to the cursors that are shown on the oscillography graph. The red vertical bar on the screen represents the trigger position on the file. On the top left side, we have the trigger date, shown here as February 20th, 2002, and the trigger time. The blue and green vertical lines represent two adjustable cursors that are available. At the top right of the window are the two slide bars that represent the position of the cursors on the display. Under each slide bar is the time reading that corresponds with the position of the cursor. If we scroll to the right, we see a yellow reading labeled delta T. This represents the difference in time between the two cursors. On the left-hand side, indicated in corresponding colors, are the signal values associated with the cursor positions. Take the F1 Current A signal value as an example. On the blue cursor is the value, negative 0.14843 amps, and the value on the green cursor is 0.94330 amps. The difference between these values is shown in yellow as 1.0917 amps. To move the cursor position, we can use the slide control at the top right. If we slide the blue cursor one position to the left, the time display on the cursor changes by 260 microseconds, and the value of the signal F1 current A is now negative 0.29295 amps. As expected, the differences shown in yellow are also recalculated. We can also move the cursors using the mouse. If we drag the green cursor to the right, we observe that the values associated with the green cursor and the delta values change accordingly. For the digital signal, we observe that the values are reported as high equals logic 1 and low equals logic 0. Another feature of the viewer is the zooming function. To zoom in on a portion of the graph, select the desired area by right-clicking and dragging the mouse. Upon releasing the mouse, you have a zoomed-in magnified view of the selected area. Two scroll bars appear on the image that enable you to adjust your view of the graph. Observe on the toolbar that the zoom-out icon is now active. If we click on this icon, the image is restored to the original scale. Another feature of the viewer is the playback function that has a start and stop icon on the toolbar. Associated with this function is a playback rate on top of the screen that can be selected anywhere in the range of 1 to 64 samples. The effect of the playback is similar to moving the blue cursor to the left with the number of positions moved equivalent to the playback rate. Let's press the playback icon on the toolbar. To stop the playback, press the stop icon on the toolbar. Also accessible on this screen is the View Phasers icon. If we click on it, a screen for phasers will appear. Maximize the screen and resize the top portion to view all the signals available. Here we see a list of all the default analog parameters that are part of each oscillography file. The colors of the signals correspond to the colors previously selected in the oscillography preferences. In the graph column, we can assign the signal to one of 6 graphs. Let's keep the currents in graph 1 and move the first 2 voltages to graph 2. If we press the play icon on the toolbar, the values from the file are played in the phasers screen. Press the stop icon and close the phasers window.
The fault report stores data in non-volatile memory pertinent to an event when triggered. The captured data will include name of relay programmed by the user, date and time of trigger, name of trigger, active setting group, pre-fault current and voltage phasers 1/4 cycle before the trigger, fault current and voltage phasers 3/4 cycle after the trigger, target messages that are set at the time of triggering, events 9 before trigger and 7 after trigger. The captured data also includes the fault type and the distance to the fault location, as well as the reclose shot number in line and distribution relays. The trigger can be any flex logic operand, but in most applications it is expected to be the same operand, usually a virtual output, that is used to drive an output relay to trip a breaker. If the element has not been reset, the OR gate output is still high, the fault report is not triggered again. Each fault report is stored as a file. The relay's capacity is 10 files. UR-PC is required to view all captured data. The relay faceplate display can be used to view the date and time of trigger, the fault type, the distance to the location of the fault in line relays, and the reclose shot number. Datalogger. The Datalogger samples and records up to 16 analog parameters at a sampling rate that is defined by the user. This recorded data may be downloaded to the UR-PC program, where it is displayed with parameters on the vertical axis and time on the horizontal axis. All data is stored in non-volatile memory, which means that the information is still retained when power to the relay is lost. For a fixed sampling rate, the Datalogger can be configured with a few channels over a long period or a large number of channels for a shorter period. The relay will automatically partition the available memory between the channels that are in use.
When you first start using UR-PC, you will notice that you have access to all of the program's features. You can view any actual values, change any setting, and access any special features such as the FlexLogic equation editor. However, access to all of these features may not be practical for a company with multiple employees performing different tasks. Ideally, each group of employees would require subsets of URPC functionality. To address this issue, the URPC security feature gives the administrator the flexibility to restrict functionality within URPC to accommodate different users. When you first start URPC, no security is enabled. URPC will assume that all the users will have administrative rights and have full access to the program. To enable security, select the menu item Security and click on User Management. The User Management dialog box will now appear. This screen consists of a user entry area and a checkbox labeled Enable Security. The user entry area, which resembles a spreadsheet, is where you will create or modify the user's security rights. Each row of the spreadsheet outlines the user's security rights, while each column of the spreadsheet will specify what right the user has. There is one user listed in the spreadsheet, and it is the administrator. This is the default user and cannot be deleted from the list. That is why all the grid boxes are grayed out and the selections cannot be changed. We'll talk about this in more detail in the Add User section. Now, to enable security, you need to check the Enable Security box and press OK. You have now enabled security in URPC. Now that security is enabled, every time you run URPC, you will be asked for a username and password. Since the user administrator is the only user available in URPC, we will log in as that user. Type the name administrator into the user field. Type the password URPC into the password field. This is the default password for the administrator. Take note that both the username and password fields are not case sensitive. Press OK and you have now logged in to URPC. Now that you have successfully logged into URPC using the administrator name and password, it's a good idea to change this password. To do this, select the menu item Security and click on Change Password. The URPC Change Password dialog will now appear. First, we need to type in the password of the user login in the Enter Old Password field. Type the password URPC. Once you finish typing the password, the rest of the fields should now be active. Now we need to enter a new password. The password must be at least 4 characters in length. Let's use Multilin as the new password. So type Multilin in the New Password field and type it again in the Re-enter New Password field. Now you need to enter a question and answer that will be used as a reminder to help you if you should forget your password. The question must be at least 4 characters and no longer than 40 characters. For this example, let's use the question, "What color is the sky?" For the answer, which must be at least 4 characters and no longer than 20 characters, we'll use blue. Finally, we need to implement the changes, but before you do that, you should remember that once you change the password, the old password will become invalid, so be sure to remember the new password. Press the Change button. You have now changed your password. At this point, we have enabled the security feature within URPC. But what's the use of security if we only have one username available to use the program? The next thing we should do is to add new users that will have access to URPC. To add new users, select the menu item Security and click on User Management. We will be adding the new user within the user entry area, which is the spreadsheet-like control in the middle of the screen. Before adding the new users, we should explain what each column represents and how it will be used. The User column holds all the usernames that have access to URPC. The Delete Entry column will tell URPC if the user should be deleted from the list. That is, this item should be checked if you want to delete the user from the list. The Actual Values, Settings, Commands, Single Line, and Enunciator columns entitle the user access to these respective features. The Event Recorder column will allow the user to retrieve and view Event Recorder data. The Flex Logic column will allow the user to access the Flex Logic Editor feature with URPC. The Update Info column allows the user to change data within the UR. This functionality must be used in conjunction with the Settings column and any other column that changing data might occur. The Admin column allows the user to have administrative rights within URPC. The reserved columns are for future enhancements. Now that we know the meaning of each column, let's put the information to practical use. We'll add 3 new users to the list. The first user will be the operator who only has access to viewing actual values. The second user will be the controller who will have the same abilities as the operator but can also change settings. The third user will be another administrator who will have the same abilities as the administrator. Let's add the first user. Click on the empty box under the user column. Type in the name of the user you want to add. For this example, type operator. Let's say the operator is only entitled to view the actual values. We'll check this box. Now, let's add the second user. There should be an empty row under the row that you just added for the user operator. Click the empty box under the user column. Type in the name of the user you want to add. For this example, let's type controller. The controller has the same ability as the operator, so the box under the column actual values should be checked. The controller also has the ability to view settings, so we'll check the settings column. And the controller also has the ability to change the settings. We need to check the box under the column Update Info. Let's add a third user. Click on the empty box under the user column. Type in the name of the user you want to add. For this example, let's type Bill, a fictitious user. We'll give Bill the same rights as the administrator and check the same boxes. Press OK to complete the changes on this screen. You now have successfully added new users to the URPC security section. Deleting a user from the security list is very simple. Let's go back into the user management screen. For this example, let's delete the user Bill. Check the box under the Delete Entry column for the user Bill. Press OK. A message will ask you if you really want to delete the entry. Press Yes and complete the deletion. Let's go back into the user management screen. As you can see, the user Bill is no longer in the list. You now have successfully deleted a user from the security user list. So far, we've learned how to add a user to the security section of URPC. Now, what if you want to modify the user's security characteristics to give the user some additional rights into another area of the program? This is very easily achieved on the user management screen. Let's say that you want to give the operator viewing access to the settings. Simply locate the operator on this screen and check the box under the Settings column. Remember that this means that the operator can only view the settings. Since the Update Info box is not checked, this user will not be able to edit their values. Press OK, and you have now modified an existing user. As an administrator, you have rights to all the features of URPC. But what if you want to test out the security rights of a user you just added? Let's close the program and restart it again. The URPC login screen should now appear. Let's check the security rights for the user operator. So, to log in as the operator, we enter operator into the user field. The default password for a new user is password, so enter password into the password field and press OK. Since this is the first time this user has logged into URPC, the Change Password screen will appear. Let's change the operator password to operator and re-enter new password field to validate it. Now, for the question and answer fields, let's use the question Name of Program. For the answer field, enter URPC. Push the Change button. You have now logged into URPC as the operator. As you will notice, some of the tree branches in the site list are missing. The areas that the user does not have access to will either be taken away or messages indicating that access is denied will be shown. We gave the operator only read access to the settings, so when you open up a settings screen, you will notice that everything is grayed out. You should now understand how different security rights are applied within the program. If you wish to re-log in to URPC, it is not necessary to close and reopen the program. There is an easier way to do this within URPC. To demonstrate this, let's log in as the user administrator. Select the menu item Security. Click on Login User. The URPC Login dialog box will now appear. Type in Administrator in the User field. Instead of typing the password Multilin in the Password field, let's assume that you have forgotten your password. You can press the Forget Your Password button. The Forget Your Password screen will appear. This screen uses the question and answer that you used when changing the password of the user, in this case, the administrator. Just enter the answer blue in the answer field. The password will now appear in the password field. Press OK to return to the URPC login screen. You will notice that the password field has been filled in. Press OK. You have now successfully logged in as the user administrator. The event log is a record of all security activities that have happened within the program. Only a user with administrative rights will have the ability to view or clear this log. To view the log, select the menu item Security. Click on Event Log and select Option View. The Event Log screen will appear. As you can see, it shows who has logged in, when the user was created, and any other security-related items. Let's clear the event log now. Close the current event log. Select the menu item Security and click on Event Log. Select Clear. A message asking you if you want to clear the event log will appear. Press Yes, and you have now cleared the event log.